Hey, what's up, guys? I'm back again to continue this bone picking that I started at the agentic AI hype craze that's been happening over the last 6 months to a year or so. And if you recall from the last video, which if you haven't seen that video, I'll leave a link to it in the description. But in the last video, we talked exactly about what an agent is, and then we went through a little bit of setup for our actual implementation of an agent. Because I think it's going to be very helpful to connect the dots between the conceptual understanding of what an agent is and what that looks like in code. So just to recap really quick, what the hell is an agent? What the fuck is an agent? It's basically has this anatomy. It has the ability to talk to a large language model. That's going to sort of act like its brain. It has usually some sort of specific prompt or system instructions around it. This is used to help orient your agent to the world it lives in and its role in it. These prompts can be uber specific, or they can be very generic. They can be very simple, or they can be uber complex, just depending on your use case and what you're trying to accomplish. There's really no right or wrong here. It's a lot of trial and error to figure out what you need to put in the agent's system prompt and its system instructions to get the behavior or the performance you want out of your agent. And then the third thing, which is really what we talked about last video, really sets agents apart, or agentic AI apart from generative AI, is this ability to call tools and functions. So this is marrying the worlds of probabilistic large language model interactions with deterministic code that a developer or an engineer has wrote to perform some specific action, right? So this could be like reading a file from disk. This could be making some sort of third-party API call. The LLM is not really calling this code, but it's providing inputs that then your system or the application that's hosting your agent is going to call, and then use the outcome of those to, again, return that back to the agent so they can continue to reason or continue to formalize its final response back to the end user. And what we're going to do in the video today is we're basically going to give our agent the brain and the identity, right? So we're going to work on giving our agent the ability to talk to an LLM so that it has the ability to understand the user's goals and objectives or its inputs. And then we're also going to give the agent a very simple prompt that sort of describes to the agent what its goals are, what it should do, what it shouldn't do. In this case, it's going to be very simplistic, but that's the objective for the video today. Get the agent talking to an LLM, and then get the LLM responding to us based on some particular prompt or system instruction that we've given to it. Okay, so that's a brief recap of what an agent is and then what we're going to try to accomplish today. And then real quick on our tech stack. So if we go back to our project setup, you might remember that we're using .NET, and we're particularly implementing it in C#, and we are also using .NET 10. So there are some features that we're using right now that .NET 10 isn't quite out yet, so it's still just in the release candidate phase. But if you're watching this video and .NET 10 is already out, then you should be fine. But you may have to go and grab the .NET 10 SDK if you're on a previous version of .NET. All right, so this is the current state of our project. We have configuration, and then we have a console.writeLine. And the only purposes of the configuration is so that we can put our API key somewhere other than our source code, and we don't incidentally commit it. This is just a good habit to get in. So let's go ahead and run this just to kind of make sure everything still works. So we'll say .NET index.cs, and that should say hello there from the agent. Cool, awesome. So what we'd like to be able to do is we'd like to basically be able to say, hey, given a user query, base your response on that user query. Use your brain to figure out what you should say back to us. In this case, the brain is the large language model. So we need to pick a large language model to talk to. And I mentioned this in the last video, but I'm going to go ahead and use the Gemini API to provide our large language model abilities. You could use Anthropic, you could use OpenAI, it's completely up to you. I just picked Gemini because they have a pretty generous free tier, and I've come to really enjoy working with their models for application purposes. Doesn't mean it's right or wrong, it just is. So at the very minimal, we need to implement something that allows us to make this type of HTTP request to their API, give it the user's input, and then allow it to send back its response. So a lot of what we're going to be doing today is just modeling this in our code, and then getting the user input and getting a response. So that's the end goal. So let's go ahead and go over to our code here. And the first thing we need to do is we need to be able to model the request, right? And then we also need to be able to model what it's going to send back to us. So let's see if we can find an example of a response. Let's see, generate content response. So we're also going to need to model this. Looks like it's got a candidates object, and that holds the content. And then the content is made up of obviously the roles, right? So you're taking turns between user and system, and then the parts. So I don't want you to get so hung up with this specific idea. This is very concrete to the Gemini API, but I want you to get stuck on the concept of we need some way to make a request, and we need some way to get a response from whatever API we're using. That is the brain of the operation here, so to speak. So let's head over to our code, and I'm going to save us a little bit of time, and I'm going to copy some of this this data transfer, right? This is just data. This is just code that's being able to serialize a request to the API, and then code that's going to handle deserializing a response from the API. So I'm going to give this a quick copy real quick. So the first thing we need is we need this candidates object. Here we go. So this is going to help us with our response. And then we also need this content object. And we need the part object. So let's go ahead and put that here real quick. And we will import this from the system.text.json serialization namespace. Okay, so the candidates is going to be helpful for when we're handling our response. The content is also going to be used in the response, and the part is going to be used in the content. And then we can use the content when we're also making our request to the API. So we can reuse a little bit of these data structures to help us with making a request and handling a response. So now let's go ahead and implement what a request will look like. So I'm going to call this I'm going to make this a record. Again, I'm using records because these objects are really just holders for data. There's really no behavior to these things. So a record is a good option for that in C#. So we're going to go ahead and say generate content request. And then that request is going to have basically right now it's just going to have one property. And that's going to be a list or an array of contents. So this, in case we wanted to send multiple contents to the LLM, we could. So we'll say this is going to be an array of content, and we will call this contents, and we'll make this plural as well. Okay, so then how do we use this, right? So the first things first, we need to actually have a way to make an HTTP request. The way we do this in C# is we use the HTTP client. So we'll say var Gemini client equals new HTTP client. And now we'll go ahead and set a base URL on this. So we'll say base address, or I guess we could call it a URI. And we'll new up a URI. And we are just going to set this to, what do we want to set this to? We are going to set this to whatever the base address is for the Gemini API, which if we scroll up, it's going to be something like this. Beta, but it's not cache content. It is generate content is what it is. Here we go. So we'll grab this URI right here, copy and paste that to our code. And let's also set this to 2.5 Pro. And then the other thing we need to do is, actually we need to make this a string and not a char. is we need to also include our API key. So, right, we have to have some way to send over to Google that, hey, we are authenticated, we do have a proper API key. So the way we do this for the Gemini API is we can do it either in a query param or through a header. I'm going to do it with a header, so we'll say default request headers dot add, and then the header we're going to add is going to have the key as our value. The key as our value is gonna have the API key as the value for the header, and then the key of the header is going to be x goog API key. And obviously, the way you know what this should be is by looking at the Gemini documentation. I just know it because I obviously did some practicing for these videos, and I've worked with the Gemini API before. So that's the first thing we're going to do. All right, and then what we would do to actually make a request is we'd have to actually new up a request and send it over. So let's go ahead and say var request equals new generate content request. And then this is going to be an array. And right now we can just make it empty, but eventually we need to put something in there. And then we'll say var response is going to be equal to Gemini client, whoops, not plus, equals to Gemini client dot post. And we're going to use the post as JSON async method here to kind of make things a little bit easier to work with. And we're actually going to post it to the endpoint. So we actually need to remove this from the base URI. So we'll yank that. Or actually, I guess we could delete that. And then we'll put that down here. So this is our target. Oops. Like that. And then we're going to send along our request. Now, this is going to give me a warning because I am using this single file app. So I think by default, the single file apps actually trim. So we need to disable that trimming so that we can get rid of that warning. So we'll just go up here and add a property that is, what is this property called? This property is called publish. So we'll say property publish AOT equals false. And once we do that, compiler should recognize that we're no longer trimming. Awesome. Okay, so now we'll have our response. Now, when we get this response back, we need to actually get the content from it. So to get the content, we'll say var content equals await. And we also need to await this call up here, otherwise things won't work the way they should. So we'll say await response dot read, nope, response dot content dot read as JSON async. And then we need to create a response object to handle this. So let's just call this a generate content response. And we will come down here and we'll make a new record. It's going to be called generate content response. And now I know a lot of this has nothing to do with AI, right, at the moment, right? We're just implementing this basic way to make API requests. But this is, when you work with a lot of those frameworks, you know, if you say you work with semantic kernel or you work with LangChain, and you're able to put together agents very quickly, this is a lot of this boilerplate code that those frameworks and libraries are helping remove from your day-to-day life, the tediousness of doing this. You're just using somebody else's code that's doing all this under the hood, right? Somebody else has built some client to interact with the API. Somebody else has built some layer of abstraction to allow you to use different clients with the same agents or with the same agent framework. So the point of doing this implementation in a very primitive way is to, again, the whole point of the video series is to try to demystify what all these tools, what all these systems, what all these marketing ploys are trying to overcomplicate, in my opinion. They're trying to lead you astray and imbue these systems with more complexity than there really is, right? There is a lot of clever engineering and hard work being done by developers and engineers to make it easy to build agents and to make it easy to orchestrate agents in complex ways. But at the end of the day, you're just talking to an LLM, you're passing data, whether it be unstructured or structured, back and forth. You're using some of that response to call other code that you have written and then return the results of that code back, right? This is the whole idea. So our response needs to have one property on it. In this case, it's just going to be an array of candidates. If you're not familiar with the Gemini API, you're probably thinking, why is it an array of candidates? Why isn't it just one? The reason for that is there is the possibility, or you can request to generate more than one response, right? So you could have the LLM send you back 2 responses, and then you'd be able to access them in this candidates array. That was kind of confusing to me at first when I saw that this top level property is actually an array, but that's the reason why it is. This is kind of like when you see in ChatGPT, or you see in the Gemini chat apps where they show you 2 different responses and they ask you to compare and pick which one was better. That's why this is there. So we'll say candidates, and now we can use that in our content. And then we should be able to print this out. So instead of saying context.writeLine agent hello there, we should be able to say, assuming everything has gone well, and remember, I'm ignoring all error handling, right? So we're not even checking if the response was successful. We're just assuming we're assuming it's successful, and we're assuming we're going to get back a properly structured response. In real world, you would have error handling here, right? So let's say content dot what is it? It's going to be content. Oh, it's going to be content dot candidates, and we're just going to look at the first one, and then it's going to be content dot parts, and we're just going to ignore that there could be multiple parts, right? An LLM can respond with not only text, but in most cases, all the APIs now support the ability to respond with parts that are of type tool request or function request, things like that. So in this case, we're just oversimplifying. We're saying, hey, you're gonna give me back one part, and I just want to look at the text for that one part. And then we'll also throw in a what is this? This is an optional operator here to say, hey, if the content is null, meaning we weren't able to actually read this from JSON into that object, it's going to be null, then we won't print anything. And then the last piece here is we don't have any user input in our generate content request. So if we go ahead and try to run this now, everything is going to break. It's all going to blow up on us because we didn't actually send anything to the LLM. So in order to make this not blow up on us, we actually need to get some input from the user. So let's go ahead and do that. Let's set a... What do we want to do? Let's set the console.foreground color. Let's set that to console color.green. That's going to be the agent's color. Let's have the agent greet us when we start this up. So we'll say, agent, how can I help you? And then down here, we'll reset the console color. Console.reset color. And now we'll say, okay, you're the user, so you need to give me some input. We'll show that as console.write. User, like that, I think. And we'll add a space here just to keep things aligned. And then we want to read in the user's query. Or it could be question, right? We could have a question. If they don't give us anything, we'll just say we have an empty string. And then here we'll say new new content, which is going to have a role. In this case, it's going to be user. And then we're going to have an array of parts, and we're just going to create a new part that's going to take in our user query as its text, and then send that over to the LLM. So now, if we rerun this now, we should find that we're prompted to provide some input. And then we'll be able to say, what is your name? And hopefully, if we've done everything right, we should get a response back. Let's see. I do not have a name. I'm a large language model trained by Google. Awesome. So now we've got our brain hooked up, right? Our agent has a brain of some sort. And we've got an extra $sign in here. We don't need that. However, our agent really doesn't have an identity, right? Like, as you can see, it's pretty much just responding to us as if it's, you know, I'm Google's Gemini and I'm its large language model, right? So we'd probably like to give our agent some sort of personality, and then likely in real world scenarios, we'd like to, again, give it a real identity and actually kind of orient it. I'm going to keep this really simple. I'm just going to provide it the identity that it should respond to me as if it's Yoda. I know it's kind of funny, but it just helps illustrate how you use this kind of prompt, right? So if we go back to our diagram here, now we're at this point where we've given our LLM or we've given our agent an LLM to act as its brain, so it can semantically understand language and reason about it. And then now I'm going to add a prompt. So this is where it's like we're going to turn our agent into, you know, an assistant, or we're going to turn our agent into a researcher. But in this case, I'm going to turn my agent into a Yoda responder agent with a particular prompt. And the way we're going to do this is we're actually going to use the system instruction field. So if we go back to our code here, and if we hop over to the Gemini API, we'll see that we have the ability to include a system instruction, which is just a content object. And that content object is obviously going to have the role of system, and then the instructions are just going, in this case, going to be, please always respond like Yoda. So let's go back to our code here. We've got to update some of these models really quick. So let's go down to our request, and we're just going to add a new property here that's going to be a content object. So it's the same as the array beneath it, but we're going to call it system instructions, I think. Hold on, let me look at the system instruction. And we are going to turn this to property, a JSON property whose name is system instruction. And then I'll make the property Pascal case just to stick with conventions here. And we'll hop up here to the top, and now this is obviously complaining because we don't have a proper system instruction as part of our content request. So we'll go ahead and just put a new line in here to make it a little bit more readable. And then we are going to new up a system content, and we're going to say, what are we going to say? We're going to say, let's see, how did I do this in my reference code? We're going to say, you are a helpful assistant who speaks like Yoda. And that should be enough for us to kind of see the impact that our prompt has on our agent, and how we can influence the way the agent responds or handles itself in response to a user query. Oh, and this should be new. Like that, and we can actually get rid of this part here because it can infer that type. Cool. So we have our system instruction, which is, hey, you're a helpful assistant, you speak like Yoda, and then we have a user query that is the user's input. So now we have, going back to our diagram again, now we have accomplished kind of the first two pieces of our agent. We have it talking to an LLM, and now we have a prompt that we've given it to sort of orient or identify, give the agent an identity. So let's run this again. And we'll just say the same thing to it, but we'll see how it responds differently. Let's see. What is your name? It'll take a minute for it to generate a response. It says, a name I have not, a large language model I am, trained by Google, I was, So this is, again, you see how the way it's responding here has been heavily influenced by the system instructions I gave it. And we can put whatever we want in this system instruction text to help the agent figure out how it should respond, when it should respond, all different sorts of things. Like I said, this can be as complex or as simple as you want to make it. All right, so I think that's going to do us for this second video. Again, I just want to help. I know these are very rudimentary implementations. We're kind of at a low level here when it comes to building an agent, But I hope what this is doing is helping you concretely connect this idea of when somebody says, I have an agent, I have an AI agent, I have an agentic system. Conceptually, all that is we have a system that can send requests and receive responses from some sort of large language model. We have a prompt that's orienting that agent. And then what we'll do in the next videos is we'll actually introduce the idea of tools and functions to really make our agent feel alive and useful, and actually give it the ability to interact with the world and do things on our behalf, and do things in a way that we can depend and count on it to actually be successful doing those things. So I hope you found this helpful. I hope you found the previous video helpful. If you haven't seen that, again, I'll put a link to it in the description. And then again, if you have any thoughts about this, if you think maybe my take's wrong about it, or if you think my take's helpful, or the way I'm talking about these things is useful, I'd love to hear from you, whatever feedback you have in the comments. So leave a comment down below. Otherwise, I'll see you guys in another video or stream or short. And until then, I hope you guys have a good rest of your day. All right. Bye, guys.